You are going to die. That is not a threat. It is a biological certainty that every human being who has ever lived has had to confront. But here is what almost nobody talks about. Your body already knows exactly how it is going to happen. Because aging is not random wear and tear, it is a program, a biological clock that was set the moment you were born, and it is ticking right now inside every single one of your 37 trillion cells. Let me show you what is actually happening inside your body as you age, and I promise you, it is far more strange and far more precise than you think. At the tip of every chromosome in your body, there is a structure called a telomere. Think of it like the plastic cap on the end of a shoelace. It does not carry any genetic information. Its only job is to protect the chromosome from degrading. Every time a cell divides, the telomeres get a little bit shorter. When they get too short, the cell can no longer divide safely. It enters a state called senescence, which is a polite scientific word for cellular retirement. The cell stops reproducing and starts sending out inflammatory signals that damage surrounding tissue. This is aging at the cellular level, and the countdown starts before you are even born. A newborn baby has telomeres about 8,000 to 13,000 base pairs long. By age 35, they have shortened significantly. By 65, they are critically short. The rate at which your telomeres shorten is influenced by genetics, but also by stress, diet, sleep, and exercise. Chronic psychological stress has been shown to accelerate telomere shortening by the equivalent of up to 10 years of additional aging. There was a landmark study of mothers caring for chronically ill children that found their telomeres were as short as women 10 to 15 years older. The study measured the actual molecular damage of caregiving stress. The implication is striking. Stress is not just making you feel old. It is literally aging you at the chromosomal level, ticking your biological clock forward faster than time itself. But telomeres are only part of the story. As you age, your DNA accumulates damage. Thousands of lesions per cell per day from normal metabolic processes, radiation, environmental toxins, and errors during replication. Your cells have elegant repair mechanisms, but they are not perfect. Over decades, errors accumulate. Some of these errors hit critical genes that control cell growth, contributing to cancer. Others impair normal cell function, leading to the gradual decline we associate with getting old: slower healing, weaker muscles, cloudier thinking. Then there is the immune system collapse. Your thymus, the organ that produces T cells, the soldiers of your immune system, begins shrinking after puberty and is almost entirely replaced by fat by age 65. This is called thymic involution, and it means your immune system gets progressively weaker every year of your adult life. By 80, your immune system is a shadow of what it was at 20. This is why elderly people are devastated by infections that younger people shrug off. It is not because the infections are different. It is because the army defending against them has been decimated. Your body also accumulates senescent cells, those retired cells I mentioned earlier, like dead weight throughout your tissues. They sit there, taking up space, refusing to die, secreting inflammatory molecules called the senescence-associated secretory phenotype. This chronic, low-grade inflammation, sometimes called inflammaging, damages surrounding tissues and is now believed to be a primary driver of heart disease, diabetes, neurodegeneration, and most of the diseases we associate with old age. They are not separate diseases. They are symptoms of the same underlying process. The most promising area of anti-aging research right now involves senolytic drugs, compounds that selectively destroy senescent cells. In mice, senolytics have extended healthy lifespan by up to 36%. Old mice given senolytics became physically younger. Their fur grew back thicker. Their grip strength improved. Their organ function reversed to younger levels. They moved like young mice. They responded to infections like young mice. Human trials are underway, and early results are encouraging. But here is the deepest question of all. Why does aging exist at all? From an evolutionary perspective, once you have reproduced and raised your offspring to independence, natural selection essentially stops caring about you. Mutations that cause damage after reproductive age are invisible to evolution. They accumulate in the genome, generation after generation, because there is no selective pressure to remove them. You were built to reproduce. You were not built to last. Aging is not a design flaw. It is not a disease to be cured. It is the absence of a reason to keep you alive. Evolution optimized you for having children, not for immortality. And that might be the most unsettling biological truth of all. Every wrinkle, every gray hair, every aching joint is a reminder that from your gene's perspective,